Thanks for coming, everyone. I don't know about you, I've been like hot all day long, so thanks for hanging in there and coming to the talk. My name is Tony. I work for Twitter in Boston. You can never guess from my T-shirt. And I talk about how we use the JVM at Twitter. Just a little bit about me, just for people who haven't met me before. I work in the VMware performance team at Twitter. Before that, I spent a little bit of time at Adobe. And before that, I was in the Hotspot JVM group, in the Java organization at Oracle. Before that, Sun for quite a while. Before that, Sun Labs. Most importantly, I've been collecting the garbage for quite a long time. Dave Bacon said I keep trying to get away from garbage collection and people keep coming, keeps pulling me back in. I just accepted my fate some time ago and I said okay, I'll just do it, somebody has to. All right, a little bit about Twitter. I don't like having corporate slides. This is just to give you an idea of, how we run things, a little bit of the scale of the operation, just will be, helpful information for what I'm gonna talk about later. So people ask, what is Twitter? Is it just a way to exchange 140-character messages? The way to see it is basically it's a platform that is real time. So to kind of see what's going on around the world in real time. A funny story was during the last World Cup. We were in the office. We were, of course, watching the matches live. I love my job. Man, everybody's like asleep right now. And we're also watching the tweets per second measure. There was like a graph. And just before a goal, the tweets per second measure will actually like shoot up maybe a second or two before we actually see the goal on TV. I'm not making this up. So Twitter is more real time than a live TV feed. It's pretty awesome. Okay, some numbers again, just to kind of give you an idea of the scale of the operation. So we have more than 300 million, what we call monthly active users. 80% of them are on mobile platforms. 40% only consume content. Basically, they just use Twitter as a news feed, which is a very good way to use it. Three-quarters of our users are outside the US. We have about 500 million users that kind of interact with some of our content every month without being an active user. Maybe they don't have an account, they don't tweet, etc. We deal with about 500 million of tweets per day. Tweets per second record was a couple of years ago, and it was 143,000, just shy, just a little bit over. 143,000 tweets in 1 second. It was in Japan. I think there is something in Japan where you watch a movie and at the end everybody tweets the same word, so hence that number. Don't ask me why, I don't know. And there have been over like 500 billion tweets since the service started. We have 3,900 employees around the world. Half of them are in San Francisco. A small number, about 140, are in the Boston area. The office is based on Kendall Square, if you're familiar with the area next to MIT, so pop in and say hi sometime if you're in the area. And half of the employees are of Twitter engineers. Okay, so services. So basically, Twitter is a huge distributed system, right? So there are thousands and thousands and thousands of machines running thousands and thousands and thousands of JVMs. I can't give you actual numbers, I'm afraid, sorry, I'm not allowed, but thousands and thousands and thousands and thousands, okay? And don't read too much into how many times I said 1,000, okay? And we have machines in several data centers. Services communicate, with each other via RPC, as you can expect. Typically, we have many JVMs per service. There could be actually a small number, one or two. It could be hundreds. Depends on the service. Depends what sort of load the service has to handle. Most services run on CentOS Linux distribution. On x64, that's the main platform that we run on. It's our own distribution, so basically we have a kernel team that kind of builds it and releases it. We run on top of an OpenJDK distribution called Twitter JDK. I referred to that before. That's what my team does. Data set scheduling is done by Mesos. We actually have a pretty hefty Mesos team that also collaborate with Mesosphere. And for the asynchronous RPC for Scala and Java, we use Finagle. Which I believe started from Twitter. And we have, it's open source, but all of the contributors are still at Twitter. This is the kind of some examples of services that, that we have, like HTTP services front end, like what to send to the website or what to send to the to the mobile app. Tweet service, when you tweet, what happens to it? How it's distributed throughout your followers. User service, user information, any other service that needs to find out about about something about you. Queries, there's the user service. Timeline service, for anybody who hasn't used Twitter, timeline is basically like the series of tweets that you see, from all your followers and stuff. Social graph service, who follows who, who's blocked who, right, etc. Interesting factoid is that the majority of the services are named after birds. So when you join Twitter and try to map a bird to what the service does, it's just like a major pain. It's, instead of saying DB, they say blah, and it's like, oh, how do you remember all that stuff? Favorite service name so far is the roast duck service. I still remember what it does. I still don't remember what it does, but I remember the name. Okay, programming languages on the server side. We use actually mostly Scala. Most services these days are written in Scala. New services are typically written in Scala. A lot of the libraries that are shared between services internally are kind of Scala oriented. There's still some Java, and some services do use Java. It's not only a legacy thing, but Scala is actually, there's more code in Scala these days than Java. Twitter started, on Ruby. But we're slowly moving away from Ruby. That's kind of typical these days. So you use Ruby or something like that in order to kind of get started quickly, and then when you need to scale, you move to the JVM. I am biased, of course, given my background, but actually that's Twitter is not the only company that's done this. There's a little bit of C++, and a little bit of Python. Like for example, for the meso scheduling, when you want to start a JVM somewhere, and then you need to kind of tell mesos how to what parameters to pass to the JVM and stuff. There is all that scripted in Python. And there are other languages as well. We acquired a fair number of companies. Each company had some legacy code in, I don't know, Clojure or something like this. It's not only this, but this is like the most the most popular languages. Of course, there's also client-side languages like JavaScript, etc. I'm talking about server-side here, okay? But what you get out of this, basically the majority of the stuff is run on top of the JVM, whether it's Scala or Java. So it's very nice. It keeps me in business. Okay, and where does my feet fall into all this? We're in the infrastructure organization. We are responsible for releasing, maintaining, customizing, and improving Twitter JDK. On top of that, we kind of provide general developer help, just some consultancy about what's the best way to do this, to do something. Does this perform better than that? And, which locking mechanisms to use because, what are the trade-offs, etc. Some kind of maybe a little bit esoteric details about the way the VM performs. People come to us to ask. We provide a lot of troubleshooting. It's like, oh, my service is GC, constantly production, what to do? And we kind of look at it and kind of try to work out, help them to try to work out what's going on. And also developer education. Like, we teach them about the JVM, how things run, what to look out for, etc. Okay, so the next few slides are going to be on Twitter JDK, and just to give you an idea how we release it, etc. So the first question lots of people ask is like, why do you deploy your own JDK? Why do you just get Oracle and get Oracle to support you? There are a couple of reasons. First is commercial support, because of course you need to be supported, right? If something happens, you need to have somebody go and kind of, fix the issue, right? If something happens in production and it's critical. Commercial support wouldn't work for us because it's basically too expensive. Typically it's like per CPU. We have thousands and thousands and thousands of CPUs, thousands of CPUs. It would just be too expensive. So, I mean, I haven't done the numbers, I don't know exactly how much it would be or whether you could get like, some rate cut from Oracle, but it's probably cheaper to kind of employ us and deal with that stuff. And also it's too slow. I mean, sometimes we have critical issue production that we could release a new Twitter JDK with like a targeted fix to deal with a specific issue within like a few hours. I don't know whether we could get that sort of turnaround from, commercial support. Also, OpenJDK development is pretty slow. Anybody from Oracle? I didn't see anybody from the VM team earlier. Okay. I still say what I want to say, it doesn't matter. So the change turnaround, it's pretty slow, right? You kind of work on something, and then, well, you have to kind of put it into 9, and 9, well, I think it's code freezing end of this year, so it's probably going to be available sometime next year, right? So, and if you want to backport it to 8, you have to get permission, and then maybe it's going to go in the next 8 release, going to be 3 months out. When we have something critical, my developers cannot wait for like 6 months to kind of, get the fix or get that feature that's going to really help them. So we have a much better, much faster turnaround with our stuff. And we're not alone. I know several companies that really kind of rely on the JVM and have a lot of investment on running on top of the JVM that actually do the same when they have a VM team. So, all right. So with Twitter JDK, like general services push the limits, the JVM's limits more than most. We have pretty large heaps. Not the largest I have seen, but pretty large heaps. We have huge scale in terms of the number of JVMs that we run and and monitor, etc. And we have some pretty strict latency requirements. So when I was interviewing at Twitter, I was like, well, why do we need like millisecond, latency requirements from the JVM? I mean, if you tweet and it takes like half a second to be propagated or a second, it doesn't matter, right? But it kind of defeats the purpose. It kind of misses the point, and I'll talk about it a little bit later. And we also, try to optimize for our stack. Again, our stack is very, is very simple. It's just, Scala, Java, Finagle, CentOS, and x64. So we actually will have it kind of easy. So we only have to build and test on one platform. Right? I don't know how many platforms Oracle support these days. Also, we try to, for Twitter JDK, we try to kind of tune things and optimize for our workloads, which actually behave quite differently compared to how, for example, Oracle workloads like Fusion middleware. That's the main thing that Oracle cares about. Our workloads behave quite differently than that. In case you don't know, so OpenJDK is not Oracle JDK. So what's on the OpenJDK sources and what's in the JDK binary that Oracle provides, they're actually not the same thing. So Oracle JDK is based on OpenJDK, but they actually add a lot of other stuff in the closed sources that they don't make public because they charge for it, like JFR, right, and a few other things. So basically, OpenJDK is actually a kind of a subset, if you want, of Oracle JDK. So of course, we don't have the Oracle secret sauce. We don't have all the secret stuff. So Twitter JDK is based on OpenJDK, and anything that that they have and we would like to have, or at least we want to have a part of it, we kind of try to recreate it. Just a kind of, I had that diagram, so I threw it in. So OpenJDK sources are in Mercurial. We use mainly Git at Twitter, so we use HGGit to kind of get the the latest updates. Actually works pretty well. Once you get the combination of the right version of Mercurial with the right version of Python with the right version of and all that stuff, it works pretty well. Getting to that point it sometimes takes some time, and then basically we build it and we get in our own repos. We have some extra changes in the code, and boom, that's the JDK that we release. We are synced to the latest update release that Oracle releases, so we don't pick up like, okay, this is the current development head, okay, so we just sync to that and then, boom, because basically, it is not perfectly stable. Every updated release has been stabilized separately, and we don't have all the, all the testing infrastructure and all the tests and that Oracle has. So we leverage all the OpenJDK testing that Oracle does already by basically basing our release to our release that Oracle has already tested. But of course we add our own changes, as I said, and sometimes we add a small number of additional patches, typically from like a later release. If there's like a critical issue that some service is hitting, and there is a fix not in the current JDK release that we're using, but like in a future one, we sometimes just backport it. Or for example, security issues will backport as soon as possible, of course. Currently, most of our services have been running on JDK 7 for a while. We've been moving to JDK 8, hoping to to be fully on JDK 8 pretty soon. We're using the server compiler, if anybody cares, in 7, but we moved to tiered in 8 and seeing some improvements, so good job there. We do monthly releases typically, so it's actually pretty cool. I work on something, and then within maybe a couple of weeks, it's out and people are testing it. It's pretty cool compared to 6 months or a year that was taking when I worked in the Java organization before. We use Jenkins for building and testing, and a lot of the testing is done in a 2-week, what we call canary period. So basically, that's kind of Twitter is not the only company that does this. So you throw part of the production load to to the system, to like the JVM that's being tested, and you see whether it works, or if it doesn't, it's okay. There are like fail-safe that will kind of migrate the request to something else, to other machines. So that's the main way we kind of finally test before we get the okay from service owner saying, okay, for 2 weeks you haven't had any issues, or oh my God, it failed immediately, go and fix it, which we'll have to do. Okay, what sort of enhancements we've added to the JDK versus OpenJDK? They're mostly hotspot. This is why we're called the VM team. And I'm doing time-wise, okay. So one of the challenges I will talk about a little bit later is to try to find out what's going on in the heap, what's being allocated, what's being retained by the garbage collector, et cetera. So we added a lot of profiling, a lot of it by sampling to kind of keep the overhead low in order to basically have running profile for services that need it about what's being allocated, like class histogram, for example, right? And then what's being retained by the young collector. That's called 10-unit profile. What's being promoted by the young collector. So suddenly, a service is promoting 100 megabytes per 10 seconds. Why? It was promoting half a megabyte before, and you kind of, by looking at the class histogram, you kind of get an idea of what's going on. At least not fully, but I mean you get at least gives you a hint about what's going on. Also full heap profiling, like every time there's a full GC or a concurrent cycle, we get a profile, what the GC found live, what the GC found dead. And we'll have like a running, a running idea of that. That turned out to be very, very, very helpful for when tracking down memory leaks. Memory leaks can actually show up, they start becoming obvious after, say, a week, right? So, and having that profile over time can give you a very good idea what's growing in the heap and what's not. One of the problems with hotspot has always been, in my opinion, that there are like too many kind of monitoring frameworks to get information out of, and not all of them showing quite the same information. So there's like, MX beans, there's like GC logging, JVM stat, I think I'm JVMTI, so there's like, I'm sure I'm forgetting something. So kind of trying to do like one logging infrastructure, because it's actually very important to kind of get logging information on what's going on for monitoring reasons. So we try to, hopefully we're gonna standardize on one. So most JVMs I know of, they have two generations, like young and old, which is pretty good if you have objects that are either really short-lived or really long-lived. So if you have what I call intermediate-lived objects, that doesn't quite work as well. So do you try to keep them in the young generation for a long time, keep copying them, or you try to push them to the old generation, early, but now your old generation grows much faster. So we did some changes to actually add more generations to G1, which is pretty cool. I don't have time to talk about it now, but if you're interested, ask me later. And general miscellaneous bug fixes and performance fixes, based on how things go in production. So, all right. So long introduction so far. So the next is kind of like the meat of the talk. I call these sections challenges, and I'm just going to kind of go over and say what sort of challenges we face every day, and maybe some ideas about some of our academic friends here, something to look into, maybe consider as an interesting problem to solve. So testing, very difficult or impossible to test a service in isolation. Why? Because as I said earlier, everything is connected to each other, right? So you cannot even get an input trace and throw it to the service, because, well, inputs come in, then a service has to query other services, get back the reply. So having to kind of come up with a way to kind of capture all that stuff and replay it is actually it's actually pretty challenging. So this is why, testing is largely done in production by this canarying process that I mentioned earlier. What allows that is basically services are largely stateless and idempotent. So if you throw a couple of requests, one to the canary, one to another server, both of them kind of succeed, that's fine. It's not going to mess anything up. Troubleshooting. So code for running services is pretty complex, right? So you have lots of developers working on it, layers of libraries and frameworks. Some of them, may be done in-house. Some of them, we, pull from, we have some open source code as well, of course. Code moves pretty rapidly, right? So something happens in production, like, I don't know, like the allocation rate goes up, or, suddenly, you GCing a lot, right? What caused it? Well, it could be like the new library that you got. It could be like some bug in the, in the code that you just pushed. It could be that another service is like throwing more load to you than it should. It could be a bug of the JVM, but of course we know those do not happen. So what's causing this? So the nirvana, kind of troubleshooting nirvana will be like you see some issue in production, it will be very quickly to be able to say, okay, it was that library that is getting the allocations wrong and is allocating, the byte arrays are 10 times larger or something like that, right? And that's really important because a lot of the time we spend a lot of time trying to get to the bottom of like, okay, why is this behavior happening now and it was not happening before? Another issue is that high-level languages and language constructs obfuscate things further. It's like, oh, I'm brain into functional programming, so, I would do like a combination of filter, map, reduce instead of having a simple loop because it looks cooler, but what sort of, performance impact that has, in a perfect world, the code would be basically ultimately the same, right? But all the time, that's not the case. So again, try to work out what sort of performance impact something like that has is kind of important that we currently lack. Another favorite pet peeve is like, immutable collections, I know that immutable collections are really cool, but man, do they take up a lot of space. So we have in the past, stirred people towards using some of the mutable collections to kind of cut down on footprint. Another pet peeve of mine for some of the JVM tools, or some of the kind of work that I have seen in literature is that, well, we have a really cool system that can give you like really cool information about X, about your program, when you run it. You run it over a system, it takes, it's going to take like 100 times longer to run, but you're going to get this amazing, detailed information, right? It's like, great, but we can't run it, right? There is no way we can actually put something like so slow on the system and actually get load. For starters, the load balance is going to say, that VM sucked, it's not responding to me as fast as I expected. Boom, redirect the load somewhere else. Also, a lot of the cases, when something is so slow, what you're measuring is actually not the application. And I have seen that. Like, I think I was in the Java org, and we're looking at some application that somebody was profiling, and they had enabled some JVMTI, I don't remember which feature, that was really slow. And what basically with the profile of the application was doing request too long, retry, request too long, retry, timeout, request, and that was it's like, okay, that's not helpful because that's not what the application is doing, right? The application is not supposed to do like real work. So any sort of profiling mechanism that takes like too long is kind of, we can't take advantage of it. We can't run it offline. It would be really cool to be able to do it in a way that, and I know it's a lot of work, I've done it, right? I know it's like a lot of work, but it would be really cool to do it in a way that you can run it and have only like a small performance overhead and get, pretty cool data out of it. The scale, like at a place like Twitter and other companies as well, will really help here, I think. We haven't taken advantage of that so much, but I think that's something I would like to get into more, is that, okay, you can have something that samples at a very low rate, but if you run for a month over hundreds of JVMs, I'm sure you're going to get a pretty damn good profile, right? So the longevity of the JVMs and also how many we run, and we collect all the profiles together, I think we can actually get something that is actually pretty statistically significant. So again, for the academics out there, think about how you can, for your next, really cool, super elaborate analysis tool, think a little bit how you could do it in a way that we could run it, say, in production with like a very low performance hit. Or maybe take like a really expensive technique that's out now and try to say, oh, look, I can actually, I propose this different technique that basically can give you the same result, but at a much lower overhead. So I think that's a kind of a pretty cool, set of, pretty cool set of problems to look into. Another approach that's kind of popular in academic papers, like, okay, we have some optimization, we like run the JVM, okay, and normally it takes 1 second, now it takes, I don't know, 58, like 1 minute, and it takes 58 seconds. Now, okay, we've improved the JVM by 2 seconds. So JVM and isolation throughput is actually not really interesting for us, and it's actually, we don't even measure it. If there is fluctuation of, let's say there's fluctuation of the compiled code by a few % up and down, it actually won't even show up in most of our measurements that we keep track of. Everybody should be shocked. So services run in clusters, as I said earlier. So what we care about is the cluster performance. So a JVM could be faster, but if it's faster but has a few worse outliers, it could actually make the whole cluster worse by basically creating like fire drills essentially on other machines when they kind of have more timeouts or responses are slow to come in, etc. So what really matters is basically the performance of the cluster, not an individual JVM. It would be cool if somebody could propose some composable models that say, okay, JVM performance changes this way. Performance, I don't talk only about throughput, I also talk about latencies, etc. Right? And then how would that affect like a cluster with these characteristics? That would be something good. I don't know if anybody's kind of looking into something like that. Also, of course, we have to measure performance in production too, right? And at different times of the day, there's different loads on the machines. So for example, 6 a.m. Eastern, when like the East Coast is kind of waking up, the load is typically lower than, for example, 4 p.m. Pacific, where California has woken up and the East Coast is still awake, right? So you have to kind of make sure that when you compare performance, you compare it, as apples to apples, as much as possible. But it's tricky. So the most important metrics that we care about, it's basically how long individual requests take for a particular service, in a particular cluster. Then we look at percentiles, 50th, typically N average, I think. And then we'll have 99, 99.9, up to 5 nines. That's what generally the most important metric in terms of kind of performance that we look at, and also process footprint. Because a lot of the time our machines are not, we could throw more calculations on the machine because there's still CPU available, but we've maxed out the memory. So we try, we keep a very close eye to the footprint of processes. Another idea that I was talking with Marius, one of our very senior engineers, and he was saying, well, there is a mix of tasks that kind of run on a cluster, right? There are some compulsory ones, like show me the timeline of user X. So if the user X wants their timeline, that they should get it. There are some optional ones, like calculate a rough favorite count. So if it's 14 or 15, well, it doesn't really matter, right? I mean, somebody might be devastated that their picture of their cat did not get 15 favorites. I mean, that's fine. But it's not like super important, right? And there are some batch jobs that have very loose SLAs. And when the load gets high, etc., some some requests requests pile up. Some requests start getting the responses start slowing down. So it'd be nice to be able to have some way to measure that back pressure. That's kind of making things worse going forward, and kind of notify the application level, saying, okay, I don't know, yellow alert. Try to drop, kind of do, not run any batch jobs for a while, or like red alert, okay, start dropping things because we're kind of getting like, completely overwhelmed here. You could do it in a big hammer way, so basically, okay, we're only gonna have up to 100 requests in flight on that JVM, but I mean, a lot of the time there is more CPU available, so might as well just take advantage of it. So it would be, so it's not a very good approach, I don't think, to kind of limit it statically. It's a much better approach to have the kind of the JVM kind of communicating to the application level, saying, yeah, I'm being overwhelmed, or oh, things are fine, throwing more load. And a lot of, what kind of affects this, what affects the running of services? Well, number of GCs our requests are survived. That means that it's getting older and older and older, the object getting older. The older an object is, the more expensive it is to handle, because now you have to maybe push it the old generation, now you have to grow the old generation, etc. Life size of the heap, the more live data you have now, the GCs would take longer, and maybe you're going to have full collections more often, etc. CPU load, etc. Okay, talking of GCs, another of my pet peeves, fragmentation. So the collector that we use most is CMS, concurrent market sweep. It uses in-place deallocation, so it is prone to fragmentation. What I'm going to talk about, though, I mean, it does apply to a lot of other systems that do have in-place deallocation. So how severe fragmentation is in CMS kind of varies from not an issue. Some services run with CMS for weeks without any problems, right? And in some cases, so severe that service fragments and allocations, cannot satisfy allocation requests within like 4 or 5 CMS cycles. Okay, and how severe fragmentation is basically largely depends on the allocation profile. So, and of course, the longer the service run, the worse the fragmentation is, right? So my pet peeve is that I really don't like papers when they say, we have this really cool new allocation scheme, right? It outperforms Dagli's allocator by quite a lot, and we proved it by running small tests for 1 second. And it's like, well, you haven't told me anything, right? So you can run a small test that take 1 second, but it's going to happen if you run a minute. It's going to still perform very well. So the fact that servers are really long running really matters, really affects how the JVM works. Not only fragmentation, but in other ways as well. Like if there is any sort of slow leak, it will show up pretty quickly. So fragmentation actually, is something which, we kind of are aware of and try to make sure we have in check in most cases. But again, for any researchers out there, make sure that that's something that you also take into account when you evaluate your scheme. Okay, I'm kind of a little bit behind, so I'm going to skip a couple of slides. Okay, huge code base. Git is terrible on that. Let's move on. So the final one that I had was, that's actually really important to me, right? It's how do you measure developer productivity? And that's something I would really like, to have a handle on. Usually these days, developer productivity is like, how quickly can you implement something? But as Ben was saying earlier, thank you, Ben, you implement something, okay, there is a cost to that, right? Because if it takes you 2 weeks to stabilize it, and by finding the few final bugs, I mean, it's fine. But if it takes you 3 months because you did like a poor job at the beginning because you wanted to save an extra day when implementing it, that's not good because you actually wasted more time. So having some sort of measure to measure developer productivity and what it means to, okay, I'm going to spend an extra day doing this because it's going to save me, I don't know, like another month of stabilization later. It's a very hard sell to management. But it's something I really believe in like, take a little more time and then you're going to save, time later. So if somebody has some good way to do this or, some measurements or anything like that, I'd love to hear from you. So I had some slides about how huge the heaps are at Twitter, how long the thing, and okay, and ask me later. So the final thing was, so what are the challenges? Scale, the fact that we have to do a lot of debugging and profiling in production. And we try to get a better understanding of running code, again, in production, and that's kind of challenging. For academics, well, work on problems that are relevant in terms of scale and duration of how, very large in terms of heap size, say, or like number of threads or whatever, and duration in terms of like, we don't care about like, 1 minute benchmarks, we really care about like 1 week benchmarks or 1 month benchmarks. And standard benchmarks in that respect are terrible. A few thank yous to some of the senior engineers at Twitter I actually talked to kind of get some extra ideas for the talk, Marius, Peter, and Stu. And I have, I think, about like 5 minutes or so for questions. Please. Thank you.
Do you care about startup time?
About?
Startup time.
Not so much. Because the VMs are pretty long-lived, a lot of the time startup time is not an issue. The only time where it's an issue is, let's say a cluster has many hundreds of VMs and then you want to upgrade the code or you want to upgrade the JVM, you have to restart them all. Then startup time becomes more important, but usually you do a rolling restart anyway. So startup time it typically is not as important as like in other situations on off. I'll let him pick, okay? So you're closer to them. So Richard.
Hi, Richard Jones. You've encouraged us academics to work on problems at scale and of a scale that is of interest to you. Now, this is an old question which we've been around for many years before. Where can we get benchmarks that are of a scale that are of interest to you?
Yeah, I think I'll give you the same answer I gave you at SMM last year. It's hard. We don't make our code available. Even if we made our code available, right? You don't have the tweet load. You don't have the machines to run on. So I don't know. I'm not quite sure what the answer is. We can all maybe all go for a beer and try to come up with one. So there are some.
Hi.
Please.
Thank you for the presentation.
Thank
I
you.
was wondering, there's research by Tim Harris into synchronizing many JVMs when they do the GC cycle. Would that help you with reducing the noise?
Would that help me with what?
With reducing the noise.
Oh,
so basically the outliers that when handling a GC, you just handling a request, you just ran into a GC.
Typically, no. GCs, in most services, GCs don't happen all that often, so they're spaced out enough that it's not a problem. The only time where GCs happen very often on like all the JVMs of a cluster is when a problem has happened. Like, for example, I don't know, the load has shot through the roof, or like the service has some sort of memory leak, so all the JVMs are pushed to a state that their heaps are full. So typically, the fact that GCs happen at the same time, like roughly at the same time, is not an issue. At least we haven't seen it as an issue so far. Yeah.
I think Tim was trying to do it the other way around, to stop the big timeouts on one, because one JVM is trying to talk to another one that's GCing.
Yeah.
He said synchronize them all, so they all GC together.
Oh, they all GC together. Oh, so now they all have lots of incoming requests that did not service, did not get service at the same time. We haven't tried that.
Okay, so you said at the outset, or towards the beginning, that during your interview at Twitter, you had this question of 5 millisecond delay versus half a second. Who cares? And you said you get to it. So is it because of the cluster effect on clustering, or what?
Yeah. I'm sorry, I forgot to get to that. Yeah, thank you. Yeah, it was basically because if a JVM starts having log latencies, then it affects everybody else. Yeah, that's what I said about the when I was talking about performance of a cluster. So it's because everything is connected. If a couple of JVMs start having long latency, then they're going to start affecting everybody else, and the whole thing is going to start slowing down. So everything doesn't run on one JVM. It basically runs essentially on many. So yeah, thanks for reminding me to mention that. Yeah.
One last question.
Last question. Yeah.
Is the JVM instrumentation work you've done open source, or do you plan to make it open source?
So we have contributed a few changes to Oracle. We haven't contributed that. That's something we plan to do, but it takes effort. So but that's something that's on our plate. So we could get to it in a little bit in the future. So.
Okay, thank you.
All right, thanks very much, everyone. And Twitter, I don't like having corporate slides. This is just us to give you an idea of how we run things, a little bit of the scale of the operation. Just will be helpful information for what I'm going to talk about later. So people ask, what is Twitter? Is it just a way to exchange 140 character messages? The way to see it is basically it's a platform that is real time. So to kind of see what's going on around the world in real time. A funny story was during the last World Cup. We were in the office. We were, of course, watching the matches live. I love my job. Man, everybody's like asleep right now. And we're also watching the tweets per second measure. There was like a graph. And just before a goal, the tweets per second measure will actually like shoot up maybe a second or two before we actually see the goal on TV. I'm not making this up. So Twitter is more real time than a live TV feed. It's pretty awesome. Okay, some numbers again, just to kind of give you an idea of the scale of the operation. So we have more than 300 million, what we call monthly active users. So thanks for coming, everyone. I don't know about you, I've been like hot all day long, so thanks for hanging in there and coming to the talk. My name is Tony. I work for Twitter in Boston. You can never guess from my T-shirt. And I talk about how we use the JVM at Twitter. Just a little bit about me, just for people who haven't met me before. I work in the VMware performance team at Twitter. Before that, I spent a little bit of time at Adobe. And before that, I was in the Hotspot JVM group, in the Java organization at Oracle, before that Sun for quite a while, before that Sun Labs. Most importantly, I've been collecting the garbage for quite a long time. So, Dave Bacon said well, I keep trying to get away from garbage collection and people keep coming, keeps pulling me back in. I just accepted my fate some time ago and I said okay, I'll just do it, somebody has to. So, all right. A little bit about, if you're familiar with the area next to MIT, so pop in and say hi sometime if you're in the area. And half of the employees of Twitter are engineers. Okay, so services. So basically, Twitter is a huge distributed system, right? So there are thousands and thousands and thousands of machines running thousands and thousands and thousands of JVMs. I can't give you actual numbers, I'm afraid, sorry, I'm not allowed, but thousands and thousands and thousands and thousands, okay? And don't read too much into how many times I said thousand, okay? And we have machines in several data centers. Services communicate, with each other via RPC, as you can expect. Typically, we have many JVMs per service. There could be actually a small number, one or two. It could be hundreds. Depends on the service. Depends what sort of load the service has to handle. Most services run on CentOS Linux distribution. On x64, that's the main platform that we run on. It's our own distribution, so basically we have a kernel team that kind of builds it and releases it. We run on top of an OpenJDK distribution called Twitter JDK. I referred to that before. That's what my team does. Data center scheduling is done by Mesos. We actually have a pretty hefty Mesos team that also collaborate with Mesosphere. And for the asynchronous RPC for Scala and Java, we use Finagle. Which I believe started from Twitter. And we have, it's open source, but all of the contributors are still at Twitter. This is the kind of some examples of services that we have, like HTTP services front end, like what to send to the website or what to send to the to the mobile app. Tweet service, when you tweet, what happens to it? How it's distributed throughout your followers. User service, user information, any other service that needs to find out about, about something about you, queries, there's the user service. Timeline service, for anybody who hasn't used Twitter, timeline is basically like the series of tweets that you see, from all your followers and stuff. Social graph service, who follows who, who's blocked who, right, etc. Interesting factoid is that the majority of the services are named after birds. So when you join Twitter, I try to map a bird. 80% of them are on mobile platforms. 40% only consume content. Basically, they just use Twitter as a news feed, which is very good way to to use it. 3/4 of our users are outside the US. We have about 500 million users that kind of interact with some of our content every month without being an active user. Maybe they don't have an account, they don't tweet, etc. We deal with about 500 million of tweets per day. Tweets per second record was a couple years ago, and it was 143,000, just shy, just a little bit over. 143,000 tweets in 1 second. It was in Japan. I think there is something in Japan where you watch a movie and at the end everybody tweets the same word, so hence that number. Don't ask me why, I don't know. And there have been over like 500 billion tweets since the service started. We have 3,900 employees around the world. Half of them are in San Francisco. A small number, about 140, are in the Boston area. The office is based on Kendall Square.